Right. Let's go here. So first of all, just to get to know you a little bit, how many here are kind of from the business side of the world? How many are actually building with their hands on? Okay, cool. So we're going to try and move that. So I'm a product manager at Microsoft. Thanks, Michal. So he's my dear colleague. I'm kind of straddling both sides, business and the technology side. And today, what I'm going to do is I'm going to try and show a little bit how we are thinking about Copilots, where we are going forward, sort of lessons that we learned. So it's more going to be kind of a stream of consciousness from my side and how we're thinking about, to uncover a little bit how we're thinking about things. Right, so I am, that looks nothing like my screen. All right, so I'm within the Industry AI group, right? So Industry AI is part of Industry Clouds within Microsoft. So what we're doing is we're building on top of the whole stack that we've got at Microsoft, starting from data in Fabric and up to Power Platform with business applications. So we're building industry-specific clouds, so industry-specific assemblies of those things, starting from data and all the way to apps for AI. Specifically, our team is building the foundations for AI only, so industry clouds have other applications as well, but obviously now we are in the age of Copilot. So, looking back, what we're going to be talking about is we're going to talk what are the Copilots, what we have learned from a product and design principles of how do you build a good Copilot, architecture, we're not going to go as deep as Gregor there, but we're going to discuss a little bit how we're thinking about things. Responsible AI and how we instill responsible AI within our Copilots, and then how do we evaluate them? Because this is one of the most important things. It's not just important to build a Copilot, it also needs to be a good Copilot, and that's a difficult thing. And then some thoughts about where we are going. You heard Gregor talk about agents. We're going to talk a little bit about sort of the higher level thinking there, and then we're going to go through sort of a conceptualization of how to think about agents. So a lot of that is going to be, a lot of this talk is going to be about, okay, how do we think about the problem, getting our language right, and because the right level of abstraction requires the right level of thinking about language and about words, etc. Right, let's dive in. So I think starting upwards, you know, I don't know how many of you know Kevin Kelly. Kevin Kelly was the founding editor of Wired magazine. Somewhere, I think in 2016, I read a book called The Inevitable. So he's got a review or kind of a preview of technologies that are going to change the world from his perspective. And one of the main things that I read then was about AI. And he said, everything that we formerly electrified, we will now cognitize. Right, and it has been paraphrased in multiple different ways. It's like AI is the modern electricity, etc. And with Copilot, this is what we're going to be trying to do as Microsoft and helping the world to electrify or to cognify all their applications and all the business processes. Right? Was just I think Paul's. I don't know how many of you were in the previous in the keynote lecture, the first one, Paul's lecture. Okay. So one of the important things there he said is that purpose is really crucial. Got my employee card, and our mission is to empower every person and every organization on the planet to achieve more. Right. So that's going to be kind of the scale at which we are trying to think about the world. Right, and Copilots, right? And we're going to be trying to talk not just about the hype, but to dive a little bit deeper. But first, let's start with the definition, right? Or one of the definitions, that's kind of how we're, our North Star from the perspective of how we're thinking about the world. Copilot is an experience using generative AI to assist humans to achieve complex cognitive tasks. And so let's kind of talk about each one of these parts. So it's an experience, right? So it's an application, it allows people to interact with it. It uses generative AI under the hood because that allows to communicate with people in the right way that is the most relevant for them at the moment of interaction. And that could be natural language, that could be generating an image, that could be generating a UI, that could be different things that can be achieved there. Assist humans, right? A copilot by itself is here for every human on the planet, right, to achieve more. And we're going to be talking about agents that are more basic building blocks that we're going to be bundling on top of the copilot. And complex cognitive tasks. We're going to talk a little bit about reasoning. And again, Gregor talked about chain of thought and how AI models reason, or how do we build systems around them that are reasoning. So diving specifically into how we are working within industry AI, we're very much following a standard product development lifecycle, right? So we do discovery sessions with customers. Michael Glaras, my colleague, is he gone? All right. So he and Michal have done a lot of work around discovery. Then we work to design. We're not just designing specific solution within our group. We are always thinking about, and I'm a product manager, right, within Microsoft, so I'm not just building with customers, I'm building the foundations. And so I'm all the time thinking, okay, what are the repeatable patterns that the different customers will need in order to build their copilots, right? So we design specific solutions, but we define repeatable patterns. And then we build with those patterns in mind, right? So we might be building something that is specific, but along the way we are developing the foundations that are going to be reusable and that are going to accelerate not just one customer, but all the customers or all the partners. And lastly, of course, we go out and we test with the customers, test with the users. We iterate very quickly because this is a field that moves quickly. And if we don't ship then and we don't understand what is missing, then we're not going to be moving forward quick enough. So promo to Michal's talk. So Michal is going to be talking tomorrow. A lot of the learnings here, and I think I stole probably some of your slides, but so you know, he and Michael Glaras ran about 250 or more workshops with customers and with partners. A lot of those learnings have been going back into our group, and we are basing on this. If you see a guy in an orange sweatshirt, that's Michael, so catch him. He can tell you about how exactly he's running those sessions. This is pretty awesome. Right, so product principles. It's not very, very complex, right? But I think it's something that, particularly coming from technology, and because the technology is very new, and the technology is something that setting a ceiling for us, right? But it shouldn't be technology for the sake of technology, as we know, right? So good old product management is not dead, right? So we need, when we are building a copilot, we need to define what the objective is, right? What is the business objective that we're trying to achieve with that? What processes are we improving? What is the value proposition? What's the value exchange between us who are building the copilot, or between the product and the users, right? It's always an exchange of value, right? They give us their time. We are providing some value into their processes and helping them achieve something. And that leads, obviously, to monetization. And monetization is how do we make money of that, and how do we exchange that value with our customers, because they pay us money, we provide them with a product. A lot of the thinking right now that is going on is around how exactly to monetize. New monetization models are emerging and are morphing all the time, right? So I don't know how many of you have a subscription to ChatGPT or to Copilot, you know, $20, $30 per month. That's kind of the current standard, going great for most of the AI copilots or basic AI copilots. But the world is starting to move out of that as both the costs of the underlying goods, the cost of the models are going down on one hand. On the other hand, the cost of interaction right now might be going up, and we're going to discuss this a little bit later. Second thing, know your user. We have to understand who we're building for, right? Again, this is a truism, this is very obvious, but what we need to understand is what processes are they going through, right? Where do they exist within the organization? Which bits our Copilot needs to interact with, okay? Who are the different counterparts that the people are encountering? And we need to map out all of these things if we want to build a Copilot. So we need to map out all the interactions, and we need to understand how the user is working and how they are operating in that world. I'm sort of saying, okay, human in the loop, responsible adult, right? We are the responsible adults who are working with Copilots. We need to make sure that both human is brought into the process at the right place. And again, I think that it's slowly shifting because we don't, as the systems improve, we don't necessarily have to review each one of the steps, and then we need to set up more guidelines and policies, etc. But we need to make sure that the Copilot that is going to be built, that it knows when to ask for guidance, when to ask for policies, when it is outside of the policies. One of the very important bits is to make sure that the Copilot is, or the human that is operating the Copilot is vigilant. By the way, this is generally with working with AI systems, it's super important. Oh, there's Glarus. So vigilance is actually a very important bit, and I'm not sure that this is so. We're going to talk a little bit about design principles, but this is something that we're thinking about all the time. It's like, how do you make sure that a human for whom the Copilot works 95% or 99% of the time stays still vigilant and knows to catch the 1% where it might go wrong? Because if we rely on technology more and more, then we develop a bias towards trusting it more and more. So this is something that is critical, and it's particularly critical as our Copilots are getting into our more and more critical situations. Right, if we've got an AI system that is working within a nuclear plant, right, and it's almost always right, we do not have the luxury of allowing even 0.1% of lack of vigilance. So designing Copilots with that in mind is very important, and something that as designers or as product managers we are thinking about as well. So let's talk about sort of our overall design principles, right? So how do we design human-computer interactions within Microsoft? So all these, so there's Microsoft Hacks Toolkit. Don't ask me what hacks. Human something experience. Human AI interaction? Okay, machine. Okay, so A stands for machine. So it's a three-letter acronym. So anyway, there's much more detail if you want to learn more, and you should learn more. And we are splitting the journey of people interacting with any AI system. We are splitting the journey into multiple different steps, and at each step we need to make sure that we understand well what the user is experiencing, and that we build the Copilot or design the Copilot with that in mind. So first of all, initially, right? We need to make clear what the system can do, and we also need to make sure that the user understands what the system cannot do, right? Setting expectations and making sure that the user comes into this with their eyes open is, first of all, it's one important bit. Second thing, okay, they started interacting. Now, what is going to be their experience during interaction? And during interaction, we need to make sure that we know exactly what are the Copilot needs to be to make sure that it is accurate, and that during the interaction the Copilot knows is anthropomorphication. We're going to leave that aside, but the Copilot needs to be designed such that when our guardrails fail, it announces that to user, and that's the when things go wrong element of the journey. Right, so the Copilot needs to, during the interaction, assess its boundaries and then know when it goes out of its boundaries. And once it goes out of the boundaries, that's where it's really important to get, and talking about the vigilance point from before, it's really important to understand what is the mode of failure for the Copilot. It's not just when it gets things right, but the most important thing is when it gets things wrong. And when it gets wrong, it needs to ask for clarification. It needs to have graceful fallbacks. saying, well, I don't know. And it needs to guide the user or to hand over to the user the wheel so that they are able to drive forward. And one more thing, and especially with systems that people are interacting with all the time, and Copilot is something that people are going to be coming back to, and something that we are improving all the time. We need to think about, okay, how do we collect user feedback? How do we close the loop with user feedback and eventually implement that as product managers? How do we implement that into our products? And sort of that whole over time interaction between the person and the Copilot, and the design of it is something that, again, when designing Copilots, it's really important to keep in mind. Right. One thing, and I'm sure that most of the people here, as we learned, are more technical, but it's something that I'm always, well, finding that people quite often are confused about. There's a difference between, and people are getting confused, between a model, a compound system, right, what something like Gregor showed us, right, where we've got multiple different elements that come together in order to eventually build an application that will provide the actual end value to the customer. And there's a lot of confusion. It's like, okay, you know, the GPT model is not the same as ChatGPT. Oops. So, you know, in the model space, you've got GPT, you've got 5.3, you've got Claude Sonnet, you've got Gemini, etc. So these are models. And then you've got compound systems. Okay, the system is composed of the model itself, some memory modules, whatever memory it has internal, whatever memory it has externally, tools that it can use, I don't know, calculators, generate code, etc. But then eventually we are taking all of that and we're delivering the value to the person that needs, you know, with the application, right? And then we're packaging that. And then ChatGPT is not just a model. It started very much as a model, right? Copilot initially was just a very, very thin wrapper around the model. But more and more what we're seeing is that there's more functionality that is being added into it as an application. And this also allows us, as people who are building products around that, it allows us additional levels of control around the experience and around, okay, how will people interact with the brains that are sitting under the hood. So let's talk about the Copilot and how we are, and what the functionality of the Copilot is, or the anatomy of a Copilot, and we're going to get deeper and deeper, I think, as we go along here. So very simply, right, we're saying that we've got a Copilot, right, which is the base application with which we are operating, and then we've got plugins or extensions or agents, and we're going to talk about that in a second, that access data sources and are able to perform actions, right? And then each one of these bits has its own complexity inside. So this is kind of how, again, this is how we are thinking about Copilot, so it's a kind of subjective view. But the basic parts that you've got is that you've got a UX, right, that interacts with the human. You've got a service which is serving the UX and is the engine behind that, which is usually what I said, compound system. The service has an orchestrator, it has some plugins, and then it goes against services, APIs, etc. And then in order to build Copilots, and again, this is something that our team is doing to a significant extent, like making sure that we've got the right compliance and security tools are in place. Some of that are built into the services that you would be using from, whether it's from Amazon Bedrock or from Azure AI or from Gemini. But there's a lot of tools that are sitting under the hood that are allowing to have the right compliance and to have the secure access, and security is getting more and more important as we are discovering the gaps that are available. And as developers, tools for developing, for testing, for cost estimations, because again, right now the technology is still expensive. So we've got all of these bits that are sitting under the hood. And some of them are actually at run, or many of them are not just at dev time, but are at runtime. Right, so let's talk about the contrast here is not where I want it. That's all right. So the industry orchestrator or the orchestrators that we're building, so we've got an orchestration, right? So that is sending the required calls to either APIs or to the language model. It brings in user context, right? So understanding one of the important things that if we want the Copilot to be relevant to the person, it needs to understand where the person is in their journey. Again, we are only now starting to understand what or how to pass all the relevant context without violating privacy and without violating security. But bringing in user context to the Copilot is critical. What interactions have there been between the Copilot and the human before? And lastly, telemetry. So this is another part of the Copilot service that is critical for us, particularly as developers. We need, but also as product managers, we need to understand how people are interacting with the Copilot. Where did it fail? Where did it not fail? Because we are on an iterative discovery and build-out journey. Industry plugins. Very briefly, we treat two plugins. One is context plugins where we are calling an external API for a particular action and then getting a return from that. That's sort of our lingo. And then we've got data plugins that are bringing in sort of complex or either simple or complex RAG, but bringing in data from outside. Tools we discussed a little bit, so we can move forward. So these are the basic parts. And then within the Copilot, sort of what dimensions do we concern ourselves with? And this is a very partial list, but these are things that need to be thought through as we are building Copilots. First of all, what is the role and what is the context of the Copilot? Right? By the way, all these are codified. Most of them are eventually codified in a system prompt for the model within the orchestrator. So it's kind of relatively, the implementation eventually is relatively simple sometimes or often, but to think through that is difficult. So what is the role of the Copilot? What context is it getting? What is the business logic? In which part of the process right now the Copilot is? What plugins are available for the Copilot? Okay, what are the tools that the Copilot has in order to interact with the external world? Localization. In what language should it speak? What units should it use? It's actually also very important to define, and especially for us as a global organization, right? This is something that we're thinking about when we're thinking about any application, and something that needs to be taken into account. Tone of voice, verbosity. Okay, do I want the Copilot to respond with just yes and no? Do I want to respond it with a longer answer? How much insight does the person want versus how much information does the person want? So that needs to be taken into account. And output format. Again, this is particularly crucial when the Copilot is speaking to it could be words, but it could be, on the other hand, it could be image. It could be a modification on the UI and, I don't know, a pop-up card, right? We are starting to move away from just a chatbot that has conversations that are ongoing with a human, and we're starting to rediscover the good old UX elements and now starting to drive them with a Copilot. And under all of that, we've got responsible AI guardrails. Responsible AI guardrails are the key elements that we are thinking about whenever we are building a Copilot. Is harmful content. Okay, do not show the user content that can actively harm them. So you've got filtering, and we're going to discuss in a second. I'm going to show you sort of a simplified architecture that we use for that. Ungroundedness, making sure that the responses are grounded in data, otherwise the response is not responsible. We always strive to have some external data source to support the internal assertions of the models. The models know a lot, but hallucinations are still not gone, and they're probably not going to be gone for a long time. So this is So we need to make sure that the responsible thing is to make sure that ungrounded responses are not returned. We need to make sure that whatever personal data is not getting leaked, and that it's getting scrapped if needed. Jailbreaking, again, if we want to make sure that we control, as the developers of the Copilot, that we control what the Copilot is able to do, because this is eventually an application. So we want to protect from jailbreaking as much as possible, so that the Copilot provides only the intended answers and refuses unintended answers. And then there are multiple other risks, and this is kind of a huge bucket, but we are always recognizing, and when we're thinking about responsible AI, we are always recognizing different elements. It could be manipulation, right? The Copilot should not manipulate. The Copilot should not be too anthropomorphized and think that it's human. And so we are putting in mitigations in place in order to decrease other risks as well. And it's kind of always important to think, okay, what other risks and it's always evolving taxonomies. Right, you can't read anything on this, so we're going to skip that. But trust me, there's sort of, I think the two most important bits on this architectural diagram is essentially that when we have a user, we've got a user message, we've got responsible AI that is filtering inputs, and then we've got responsible AI that is filtering outputs. That's kind of one thing one design pattern that we know that we always put in. We're not going to dive into all the rest because you can't see. Right, and then after we've built the Copilot, now we need to test and evaluate it, right? And we test and evaluate it against two important metrics. And by the way, very often, particularly in the last year when we just started, it's like, okay, let's build a Copilot, let's get it out in the hands of the customers. But do we actually know that it does what we are intending to do? Do we have the right, did we assess quality? And I must say that in the beginning, it was just get it into the hands of the customers, make people play with it to understand generally the capabilities. Now I think we're getting much more responsible as an industry. And we are all the time thinking, okay, is the Copilot really delivering the quality that we're expecting it to deliver? And then the second thing is safety. We talked already about responsible AI. And by the way, of course, there's a trade-off between the two, right? So if the safest Copilot is a Copilot that does nothing, right? So this is minimum intervention, so it will refuse everything, but then it's not going to be useful. So you are always treading that line somewhere. Very briefly, kind of what are we measuring when we are saying effective? We want to make sure that the answers are grounded in truth, right? So truthful answers, that they are relevant to the customer's situation and where they are currently positioned. We want to make sure that it's clear that whatever the Copilot is responding is clear, because that is also one of the most important things, is that the level, for example, of, I don't know, if I've got a financial Copilot, the level with which it's going to speak to a layperson is going to be completely different than the level at which it's going to speak to a financial advisor, right? So we need to make sure that the conversation or the Copilot responds clearly, and that the response is complete, right? So very simple. How do we go about doing that? We've got two assessments, essentially, and again, not rocket science, but we've got AI assessment, right? So we've got another AI that is checking the responses. By the way, works pretty well. GPT Judge, kind of as a pattern, so Google it. It's really working well, and we found great success. And by the way, I don't know how many of you know the internals, but generally speaking, Anthropic are driving all of their, or most of their models through AI assessment. And then we also add on top of that expert assessments, both to train and to make sure that our AI assessment systems are assessing all these elements correctly, but also doing sporadic checks. And then me as a product manager or my team, what we make sure is that the quality bar is defined, right? And that we know that we have put out against each one of these elements, that we've put out a particular bar before releasing anything. On the risk side, so we discussed many risks. These are the 3 risks that are most critical for us. So sensitive content, jailbreaking, and groundedness. These are the things that we are always checking. A lot of the work that we're doing for safety evaluations is through red teaming. Red teaming is a technique. It systematically evaluates weaknesses that we've got in a system. How do you execute a red teaming exercise? So you plan. And then when we're planning, it's like we're saying, okay, so who's going to be doing red teaming? It's not fun. You know, because you need to review outputs, and even if the outputs were tagged, if we've got an AI that is doing some of the AI assessment, some of the responsible AI assessment, then we still need to make sure that a human reviews the outputs. By the way, these outputs can be pretty nasty, as well as the inputs there. So we need to make sure that we understand who's going to be in the red teaming group, and we need to define. By the way, this is also modulated on the level of, depending on the riskiness of the use case, right? If I've got a more risky use case, which is involving healthcare or involving access to credit or in financial services, so these are more sensitive users. For those sensitive users, we would always have red teaming exercise outside of the product group. For lower risks, we would have red teaming inside the product group. Okay, what are you going to be evaluating, right? It's like, what are the sets of questions that you're going to be pushing through the Copilot in order to evaluate their answers? How exactly are you going to be capturing the feedback? How exactly are you going to be evaluating the outcomes of red teaming? Then you execute the red teaming, and then you put in mitigation actions in place, right? So you modify the system prompt, or you modify the guardrails in the beginning or in the end, filters, etc. And of course, we're not doing the red teaming exercise just once, but we are repeating it. So I think that this is more or less what kind of gives a high-level framework of, okay, how we're thinking about Copilots, right? So we talked a little bit about the product and design principles, about the architecture, how do we deal with responsible AI, how do we deal with evaluations. That was kind of looking back, so I was pretty certain of what I'm doing there. So a few words about kind of, okay, where are we going? And starting from here, it's more of a speculative, so I think I've got another 10, 15 minutes. So this is more of a speculation of how we're thinking about the world as it evolves right now. And you will have heard and you will hear over the next many months is that agents are everywhere. This is kind of probably the word of next year. We're going to have all those predictions starting from November, all those predictions, what will be the year of 2025. 2024 was multimodality, and it was reasoning, etc. So it's all going to be about agents. By the way, agents are completely not new, right? So there's plenty of things that have been developed 80 years ago almost on the topic of agents, right? So basic principles of cybernetics assume that we've got agents. We're going to talk a little bit in a second what is an agent. So an agent is an expert system that operates autonomously on behalf of, and notice here is that this is our definition from yesterday's blog by the leader of our area, on behalf of a process or a company, right? So an agent does not necessarily operate on behalf of an individual human, right? We've got the Copilot, and then the Copilot is now a system or an application, and that becomes, it triggers agents and as part of particular processes. So an agent does not have to be an individual agent. Right, but why? Right? Why do we need agents, and kind of, where did this come from? And again, this is a speculation, but kind of how we're thinking about the world, again, is important, and why we're doing things, and some introspection is probably important. So first of all, if we look at the Copilot applications, we can broadly say that we've got two types. And by the way, we have not yet achieved success, despite us being on the journey for the last year and a half, but the world has not changed yet, and kind of thinking about why not yet. So we've got generalist agents, right? So ChatGPT has about, what, 200 million users or something like that, so decent. And I think in the B2C world, we're seeing more and more adoption. But this is not the business world, right? Microsoft, we are very much oriented towards the B2B world, and particularly our area within industry AI, right? Our objective, as another illustrious leader that we've got says, our objective is to capture 3.5 billion professionals in the world. And if we look at where we have been successful as Microsoft until now, we've been successful with GitHub Copilot, right? So over 1 million developers around the world are using GitHub Copilot to write code. We've been successful, most of you probably are not familiar with that, Nuance DAX Copilot. So this is a Copilot for medical professionals to take patient notes, right? Now, what is similar for both of these professions? Both of these professions are highly educated people who are paid a lot of money that do something that is, or that have a portion of their job that is highly repetitive and is dealing with generation, right? So it's like a very simple, relatively speaking, it's a very simple problem to solve, right? So a software engineer, yes, they are designing the system, etc., but they still need to write a lot of the code, and they spend a significant portion of their time, or you guys are spending a significant portion of your time on writing code. Same with a doctor. The doctor is writing patient notes. It's not a small task. It actually is very time-consuming. Again, highly paid individuals, highly trained. So these are the cases where copilots have been successful or widely successful. And then, if you think about why is it difficult to access all the workers or all the professions? And I think that one of the main points is that most of the people, even those who are working on a computer, most of them are interacting with other people, right? The processes are very broken, right? We have not yet completed the digital transformation that we started from 20 years ago, right? So the automations are not there. The processes are still very much disjointed, both on an individual level as well as on the level of human interaction. By the way, some of that is by design, right? Many of us like working with other people, and so some of that is by design, that we are building processes such that people are interacting with each other. And therefore, it's not one repetitive task that I can perform and that I can charge for a highly, for an individual that is highly paid. So we need a different paradigm, right? If we want to capture all the different business processes, we need to have a slightly different paradigm that is going to be able to take a particular process, right, and across the organization to weave different parts together. Actually, we've got many limitations of the current generation of copilots, right? So they are very bad at performing multiple different tasks, right? So if I've got a copilot, I've defined the system prompt for it, right? I can't, at the moment, I cannot define many different things that it's going to be doing. The copilot right now is mostly not proactive, right? So it requires us to actually prompt it, right? People are lazy, people don't want to prompt anything. So that is the limit on how much we are interacting with it. The copilots are still prone to hallucinations despite having been grounded in data. The context is limited. It's generally stupid, right? There's still reasoning gaps, right? The copilots cannot, or the underlying models cannot really reason, and we can discuss that. It's actually getting better and better, and I'm highly optimistic in that regard. But that leads to us needing more complex architectures down the line. And agents are allowing to reason and to reduce that complexity somewhat, right? And to have repeatable building blocks that are smaller building blocks. By the way, you know, again, for the developers here, the right abstraction for an agent is probably microservice from sort of how to think about that. It reduces the complexity of each individual element. It increases composability, and it allows for dynamic planning, right? That is not pre-coded potentially into sort of which parts of the process to touch. With agents, we are able, because of the composability, we are able to enable better controls along the path. And one item that's pretty technical, but I think is important, is that I don't know how many of you are familiar with the O1 model from OpenAI, but one of the breakthroughs recently was that we know that if we allow the model to think for a longer time, or to process, or to get more compute then we get better reasoning results. And that is one of the reasons why chain of thought is working, that essentially it's just generating more tokens to get to the final insight. And one of the ways to scale that is through agents that are discussing or that are passing information throughout and are making multiple addresses to the model, eventually getting more tokens generated, and this way it overcomes some of the reasoning limitations that we have. Right, but what is an agent? Right, and I think that this is kind of, people are sort of hand-waving. Again, this is one of the definitions. This is not the only definition. It's not even a definition. I think it's kind of a thinking framework, something that I drew up. So this is, I don't know if it's supported by a lot of external references. Essentially, an agent, in a very simple way, it can perceive its environment and then it can act on its environment, right? That's kind of very simplistically. In order to do that, it needs to have a particular goal, right, in order to be able to act. And then, in order to be able to perceive the environment, it needs to have a sensing mechanism, right? So it needs to, a sensing mechanism could be a trigger that is, you know, very simply, a trigger that is being, or even a timer, right? A timer is a kind of a sensing mechanism. A trigger from another application or from another agent is a sensing mechanism. It needs to have an element of reasoning, right? It needs to be able to transform inputs into outputs. And then it needs to have a set of capabilities, right? Arms and legs. It needs to be able to do something, right, in order to act. And then lastly, it needs to have an understanding of its internal state, right? It's like what it has done, what it has not yet done. So that's the other bit. Right, and once we've got all of these figured out for our agent, then we can start building with it, right? Start building or start employing that. And we are employing, I'm intentionally saying that this is a principle that actually doesn't have to be a human, right? Somebody needs to set the goals, right? So you've got a principle, right, that is operating the agent, or on whose behalf the agent is operating. And then they set the goals, and then they consume the results. And then they can iterate onwards, right? And as I said, it doesn't actually have to be a human. Right. Additionally, if we are talking about sort of smart agents or more and more complex agents, then we want their knowledge of the to evolve over time, right? Their state and their overall knowledge base to evolve over time, and then we wanted to be able to develop new tools or acquire new tools, right? And that's where the future is going, where the agents are going to be able to construct their own set of tools, whether it's through recombination of existing tools, whether it's by generating code on the fly and then putting it into a library, etc. And then what we can do, as I said, the principle doesn't have to be a human, is that agents interacting with other agents would be able to set goals for the agents, and then the sub-agents would be able to update the state, and I'm sort of lovingly calling dispatcher mode, right? So who's dispatching the different agents. Each one of the agents, again, the way to think about this or to reason about that is to say, okay, an agent has a zone of influence, right? It senses a particular portion of the environment. They might be overlapping, and the environment could be a software environment, could be whatever, my set of emails that are in my mailbox, right? And then I'm going to have one agent that is, I don't know, sorting through and extracting invoices, another one that is able to respond and, I don't know, say happy birthday to my mom, or bad idea. Right, and then this basically is forming what people would say a swarm, right, where you've got a user. The user has, and this time it's a human user, the human user would have a copilot. The copilot employs one or more agents that are themselves employing other agents. So this is the pattern where we are currently moving into. And you're going to hear a lot of chatter about kind of these kinds of frames of references in the next few months. More or less, we're almost at the end. So there's nothing permanent except change. So this is something that we need to embrace, something that I'm trying to all the time think about. And we've got sort of fallacies, right? And the fallacy is that, I don't know how many of you know Wait But Why or know this chart. I love it. It's kind of one of the things that are guiding me in how I'm thinking about things is that, okay, we actually don't know where we currently are, right? So, okay, so we're humans, okay. Oh, this funny robot can do monkey tricks, right? It's probably already somewhere here on the level of a dumb human. Some would say a PhD student is a dumb human. And then, that's the latest models are at the level of a PhD student, or so they say. But we've got that fallacy, right? And that fallacy is in the fact that actually things are, to a significant extent, exponential. And they're exponential not just because we've got more and more compute and more data, but also in how we distribute knowledge between us humans. You guys are all sitting in the room, and we are exchanging knowledge, right? This is something that we've been doing for millennia, and this is one of our superpowers. And that's why we are putting in more and more things that eventually are driving the intelligence curve to be exponential. And by the way, on the left-hand side, it will still look like, okay, I don't know, it's going to be stupid, don't look stupid all the time, but on the right side is the fuck. And because there, if reality overshoots, it's going to look very surprising. So this is kind of one thing that I'm all the time thinking about, and where are we on that curve, and how far are we? And of course, there's Amara's law. We tend to overestimate the impact of things of technological advances that are close to us, but we underestimate the future. And we are pretty rubbish at this, and so we know, again, knowing our own cognitive biases is very important as we are thinking about, okay, how do we develop the next generation. And lastly, nothing is true but change takes time. It takes time to shift organizations. It takes time to pivot them. We are seeing everybody's pivoting, and it takes us time to understand what works, so we need to be patient with ourselves. Slowly, however, this truth or whatever our future direction is emerging, and this is a fun journey that we're on. So welcome you to build and steer forward. Thank you. Questions? I have no idea how that works, if that works. Very bottom.
Thanks.
Yeah.
So I have a slight curveball for you. So I've been using GitHub Copilot for over a year now, and I haven't seen once asking for clarification, saying, I don't know. It always spews answers, and some of these answers are really bollocks. Some stuff is really completely made up. So my question to you, is there any way we can actually address it, like short term? Because, well, you already mentioned this. Hallucinations are essentially not a bug. They are a feature of language models. So how do we work with this? Especially, well, you mentioned that, well, there is also a Copilot for, say, medicine, right? And that's where things get really serious. How do we work with this?
Well, first of all, I think one of the elements is to be patient. I don't have a good answer for you, right? It's like, I think it's like being vigilant and knowing when to, knowing the limitations of the tools, right? It's one thing. I think, and by the way, this is an interesting point that you're raising. It's a GitHub Copilot is actually one of the older, the oldest ones, and it's been an inspiration for the word Copilot and why we're talking about the word in that way. But kind of, this is the problem with successful products, right? Or with the successful first generation of products. By the way, there are other elements that are better around, or that there are other competitors to GitHub Copilot, right? Cursor, for example, or Codium. I think Codium have renamed. So there are competitors. I think that as we go forward, and again, this, I think as users, what we need to do is to be vigilant and know the limitations. As product managers, we need to make sure that, I'm not the product manager for GitHub Copilot, so, but as product managers, we need to understand when we need to disrupt and move faster and not be afraid to break some experiences that work for people, to an extent at least. But then we need to evolve very quickly. By the way, I know the team is under a lot of pressure from the community. And as community, it's like be proactive and reach out and highlight the limitations.
Thanks.
So I have a question about the Copilot and the context. So is it possible to build, let's say, some kind of assistant that will remember the context that I am providing every day?
Yes.
Yep.
Yes, it's possible,
Yeah,
and it's being done.
Okay. Yeah. So the next question also, it has been done already. Do we have some kind of product that is some kind of assistant that will remember all the things that I will talking with him and the decision that I'll make, and just to be a real, the next person said to me and help me in everyday life.
So two elements, or actually three. So first of all, I don't know how many of you, again, have looked into ChatGPT. Within ChatGPT, you've got memory function. It's rubbish. I don't like it. Sorry, not politically correct. But it sort of, once in a while, when you're interacting with it, it would say, saving memory. And then it kind of summarizes an element of your interaction, and then it puts it into its own working memory. So, for example, my ChatGPT knows that I'm a product manager at Microsoft. But then I really wanted to delete the Microsoft because I actually don't want that saved. And this brings us to the second problem, or to the problem of keeping memory, is that you don't necessarily want the Copilot at every point in time to know everything about you, right? So that is a design problem that I don't think that we have a solution for yet. Of, okay, how do I really control well what it needs to extract at any point in time, because I don't want, I don't want it to always remember everything about me, both from a privacy perspective as well as from functionality perspective, right? Because maybe I wanted to cross-validate something that that it might think that I already know, right? But I intentionally want to ask that, right? So we don't have good controls for that, something that we're working on. One interesting bit, again, don't know how familiar you are, but Mustafa Suleyman, so he used to lead Inflection. He's now our CEO of Microsoft AI and co-president or president. But basically, one of the things that his previous product and one of the things that Copilot right now, the private Copilot that is currently doing, is it's maintaining essentially a conversation that is just one single conversation. You actually, Copilot, you can still force Copilot to refresh the conversation, but you need to kind of go intentionally. You need to go 3 or 4 clicks to a different screen, and then only then you will start a new chat with the Copilot. Again, with the intention that all your interactions with the Copilot are going to be remembered and referenced in the future. So we're on that journey.
Okay. There you go.
Yeah, so I have a question because I previously was researching plugins for Copilot, and there was a graph connector that actually reminded me of all your presentations. So am I understanding correctly? So this graph connector and everything connected with this part is about the future. So you're going to extend it, all this taking information from the Outlook, from the everything connected with Microsoft is what you're going to build.
So first of all, it's already, as you said, there already are graph connectors, right? So for people who don't know, essentially whatever information that you've got within Microsoft 365, which is PowerPoint, Outlook, Word documents, whatever is in Teams, SharePoint. So all of that is kept within a big database, which we call Substrate, and the interface between Substrate and other applications is graph connectors.
One thing to call out, don't look for Substrate in the Google because...
Oh really, is it internal
yes,
only?
it's internal name.
Because I did find it, anyway, it's like, it leaked. Well, basically Microsoft Graph is the interface to all the information. Some of that information has already been pre-crunched, a lot of that has been indexed. You can also put in external information into the graph as well. Again, then a copy of that information is going to be kept in the graph or in Substrate. So it's already happening.
Yeah, thank you.
Thank you. Yes, so you mentioned that the safety is quite a big of a trade-off when it comes to the quality of the answers the models are getting. And I would like to ask you about the good practices, because when you're creating agents to do, or so-called microservices to cover just a specific task, is it any good practices to force agents to do only what they are supposed to do? And of course, the basics are covered by the model itself. But for example, if you would like to make an agent that search for the specific group of products, and we can do it manually to force them to search within the domain or whatever. But maybe there is another way to cover that. Create another agent that will try to accomplish your goal to only give the answer that you are aiming to.
So I'm not sure I fully understood, but let me try and potentially rephrase it. So the way so there's a number of different things. So first of all, from responsible AI guardrails, right? So you've got layers upon layers of things, right? So you've got the model itself that has been fine-tuned and has some guardrails built in. Then you've got within Azure OpenAI, for example, when the model is being exposed, you've got additional filters that are within the API of the model, on the layer of the API of the model. Then you've got essentially whoever sent your agent to search for whatever, right? It's like, so your Copilot has its own guardrails, both on the input and on the output. Then the agent itself has its own responsible AI guardrails on the input and the output, right? So you've got layers upon layers of these, and you need to be, as a developer, you need to be aware of, okay, on which layer do you want to limit things? This is one thing. Just one sec. And then the second, and then the second thing is that, again, turn a lot of the patterns that we're seeing are, okay, turn the probabilistic into deterministic, right, behaviors. I.e., if you know exactly what your agent should be doing, then it should have an API to access that is then calling, has a very defined function, right? So it doesn't have to be to search by itself. So then you have a completely stupid element, right? And again, if you look thinking about the brain, this is kind of a lot of how our brain's working, right? With subsystems, I'm standing here and I'm keeping my balance because that's only one part that knows how to do only that thing.
To supplement that, you will find a lot of sessions about the AI Copilot kind of security from the tools perspective, reviewing the sessions from last build. So if you go to YouTube and we'll say build 2024 AI security, you will find at least 2 good sessions. One is done by Mark Rusinovic. He's showing a generic Gen AI architecture, application architecture, and it gives you a lot of thoughts where the risks can come from and what things we are trying to productize as a way to overcome that. The second session is done by the team who created a framework which is called Pirate. Python, Risk, whatever. Sorry, I don't remember the longer name. But the whole, if you will put Pirate in Google, you will find it. Or in your preferred search engine, as we like to say at Microsoft. But anyway, this Pirate framework will help you to figure out many ways how you can test your apps. Guys, does this answer your question, by the way? Okay, we are over time. Thank you, Ilya, very much.
Thank you.